Hi students, in this video we're going to do some problems involving trigonometry, but in situations that require some 3D diagrams and modeling. Right, so after watching this video you should be able to visualize triangles in 3 dimensions, draw and label diagrams for 3-dimensional problems. These next two are quite important, so recognize that angles of elevation and depression can be seen from a side view, and recognize that bearings are seen from a top view when looking at a 3-dimensional problem. And then using all your diagrams and your trig ratios, solve problems involving trigonometry in 3 dimensions. Right, key things you have to recall are your trig ratios, sine, cos and tan, and labeling your sides. The main skill that's going to be new that we're going to be talking about today is drawing those 3D diagrams. Right, so the most important skill in solving 3-dimensional trig problems is drawing accurate diagrams. Okay, I cannot state this enough. It's hard to get your mind around all the information in a 3D problem because on a 2D page we can only really draw 2D shapes effectively. So what we need to be able to do is get some practice and do some skill building, working out how do we draw in 3D and then convert that 3D diagram into a 2D diagram that we can solve and we can use really easily. Now there are 3 types of diagrams that can be useful in solving 3D problems. So first of all is your 3D diagram. Now your 3D diagram contains all of the information that's given to you in the question. So there's going to be a lot in it. It's going to be condensed in a smallish amount of space, or big depending on how much of the page you're willing to use for it. But the moral of the story is it's hard to get all of your it's hard to read all at once and get all of your information just from one viewing. So 3D diagrams are a good place to start to collect all your information, and then you break it down. These other two views, which are the top view, where you can see directions including bearings and horizontal distances along the ground. So let's say we've got a point here. We might have a triangle that looks something like this. We might know that's north. And then we can get our bearings from here. That might be 120 degrees true. And then this here, or the angle around to here, might be 200 degrees true. So we can see bearings with a top view because we know north is going upwards. Then we can get our bearings from there. Now with our side views, you can see angles of elevation and depression. So we've got our person here looking at some object. In this view, you can see the horizontal distance between the person and the base of let's say it's a building. You can see the horizontal distance between the person and the building. You can see the distance between the person and the top of the building. You can also see angles of elevation or depression there. So these are your 3 views. Your 3D diagram that has all of your information. Your top view, which you take from your 3D diagram, which just contains the bearings and the distances between objects horizontally. And then you can use your side views as well, which you can see your angles of elevation, depression, along with your horizontal distances and these slanted or direct distances as well. Right, so with these 3 diagrams, we might look at one of these problems here. So Rob and Eric are surveying a park. Rob is standing 32 meters south of a large pine tree and has to look up at an angle of 34 degrees to see the top. Eric is standing due east of the tree and has to look up at an angle of 30 degrees to see the top of the tree. Determine how far Eric is from the base of the tree. Alright, so our first step, guys, here is to draw our 3D diagram. So let's say we've got our tree here. And reading through the question, we don't know how tall the tree is. Let's just give it a letter. We'll give it a H. H for height. Alright. Now we need some directions. Let's say up this way is due north. So down this way will be south, and that will be where Rob is. Now Rob, we know, going due south is 32 meters. So he's in here, 32 meters south. And when he looks up to the top of the tree, that angle there he's looking up at is 34 degrees. We also know we've got a right angle in there as well. All right, that's for Rob. Now and then for Eric, we know Eric is due east, so he's along here. Eric is east. It's nice that E can be for Eric and for east. And to the top of this tree, he's now looking up at an angle of 30 degrees. And his distance from the tree, we don't know. In fact, that's what we have to find. Eric's distance from the base of the tree is what we have to find. Let's just call that X. And we also know that we've got a right angle triangle here. We assume it's nice and flat and a right angle for the tree. All right, so there's our 3D diagram. We've got our tree up here. We've got Rob due south, 32 meters, looking up at 34 degrees. We've got Eric due east, looking up at 30 degrees, and we've got this distance to find here. All right, so we've got our 3D view. Let's now take this and draw some side views. The first side view we might draw might be for Rob. So for Rob, we know he's 32 meters south. We've got our tree, which is some height there. And then when he looks to the top of the tree, we know that's 34 degrees. Right, looking at that triangle, we can work out the value of height. Right, so using trigonometry, that side's opposite, that side's adjacent, so we can use tan. So tan theta equals opposite over adjacent. So tan 34 degrees equals h over 32. Rearranging that, h will equal 32 times tan 34 degrees. Now we could get a value for that and round it. What I'd rather do is leave my answer in this sort of form. So this is called exact form, right? Because we haven't done any rounding. As soon as we turn it into a decimal, we'll have to do some rounding somewhere, and that means our answer will be a bit less precise and a bit less accurate. So I'm going to leave my height in this sort of form here for the time being. All right, that's our first one. Now let's draw this second triangle for Eric. So for Eric, we've got our tree here and this distance along the ground, which we don't know yet. And then we know Eric has to look up at 30 degrees to see the top. Now, once again, we've got a right angle triangle here, so we can use our trigonometry. That's our opposite side, that's our adjacent side. So once again, we can use tan. Tan of an angle equals opposite over adjacent. Tan 30 degrees equals h over x. Now h we know, it's 32 tan 34 divided by x. Now rearranging this, right, I'm going to multiply both sides by x and then divide by tan 30. So just doing that rearranging pretty quickly, we're going to end up with x equals 32 tan 32 degrees over tan 30 degrees. Put that into your calculator and you get a value of 37.89 meters. So that means Eric must be 37.89 meters away from the tree going this way. Right, so after watching this video, you should be able to visualize triangles in 3 dimensions, draw and label diagrams for 3D problems, Recognize that angles of elevation can be seen from a side view, like what we did in that example. Recognize that bearings can be seen from a top view. We sort of explained that in our notes, but didn't really use that in the example. And then solve problems involving trigonometry in 3 dimensions.